Apollo 13, planned as the most challenging lunar landing mission to date, destined for the hilly Fra Mauro formation of the moon, became the most crucial test for men and equipment in America's manned spaceflight program. On the third day of the mission, some 200,000 miles from Earth, loss of the main oxygen supply aboard the spacecraft caused the scheduled lunar landing to be canceled. The ability and ingenuity of the Apollo 13 astronauts, the ground controllers, and thousands of engineers and technicians throughout the country were required to effectively carry out the established backup plans of Apollo for survival in space and return the spacecraft safely to Earth. December 1969. Rollout of the Apollo 13 space vehicle was witnessed by the 3 astronauts assigned to the mission. Spacecraft Commander Jim Lovell, a veteran astronaut, highly qualified through experience gained in 3 previous space missions, a total of 24 days in space. The other members of the original Prime crew, both assigned to their first space mission, Ken Mattingly, the command module pilot, and Fred Hayes, the lunar module pilot. During the countdown of the Apollo Saturn V space vehicle, command module pilot Mattingly was replaced when medical results indicated a possible infection of measles. His replacement was backup pilot Jack Swigert. In the spacecraft simulator, Swigert demonstrated that he could function with unquestioned teamwork with the other members of the Prime crew and perform all of the maneuvers required for the command module during the mission. The decision was made to launch on schedule. One of the smoothest countdowns in the history of manned spaceflight was conducted by the Kennedy launch team.
Go. T-minus 20 seconds. T-minus 20 seconds and counting. 17, guidance release. 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence has started.
Took place on Saturday, April 11th, 1970 at 2:13 p.m. Eastern Standard Time. The first stage engine shut down at a 40-mile altitude, and separation took place as programmed. Although within planned tolerances, the center engine of the second stage shut down 132 seconds earlier than predicted. The early cutoff was compensated for, and the planned orbit insertion was achieved by both a longer burn of the 4 outboard engines of the second stage and a 9-second longer burn of the third stage engine. The spacecraft and third stage were placed into a near-Earth circular parking orbit. After a thorough checkout of all systems, Mission Control gave the crew go to leave Earth orbit on schedule for the lunar trajectory. About 2 hours later, the command module was maneuvered into position to dock with the lunar module and removed it from the third stage. In all previous lunar missions, the spent third stage was sent into a trajectory in an attempt to orbit the sun. On this mission, the plan called for a different use of the stage, purposely impacted on the lunar surface at a predetermined time and point. The impact, comparable to 11 tons of TNT, occurred on the third day of the mission as scheduled and created a moon quake. It was recorded by the seismometer left behind on the Apollo 12 mission. The tremors and reverberations on the moon lasted almost 4 hours. Peak readings of the seismometer traces were 20 to 30 times larger than the lunar module's impact on the previous mission. Scientists called this extremely significant, a finding which necessitates disregarding the Earth as a seismic model of the moon and which could force reconsideration of all theories so far proposed about the lunar interior. In the early part of the Apollo translunar flight, about 30 hours into the mission, a planned course correction was performed. This moved the spacecraft off of a free return trajectory into a new trajectory, which would bring the spacecraft closer to the moon on the initial lunar orbit. 54 hours after liftoff, the crew entered the lunar module for the first time and checked all systems. The crew had previously selected the code name Aquarius for their lunar landing craft and the call sign Odyssey for the command module. About 56 hours into the mission, the crew had the first indication of trouble aboard their spacecraft. They calmly relayed,
"Okay, Houston, we've had a problem here."
This is Houston. Say again, please.
We had a pretty large bang associated with the caution and warning there. And it looks to me, looking at the hatch, so we are venting something into space.
Roger, we copy your venting.
Mission Control immediately alerted all ground personnel and began to initiate the necessary procedures to alter the mission plan. Because of the damage to the service module, there was an increased load on the remaining fuel cell in generating essential electrical power and manufacturing water. Pressure in the remaining oxygen tank was also diminishing. This led to the decision to cancel the lunar landing and return to Earth. Mission Control also decided to activate the lunar module, turn off all equipment in the command module, and use the systems of Aquarius for life support. 2 of the crew transferred to the lunar module and prepared the vehicle for the alternate procedure called the lifeboat mode. The lunar module Aquarius would now supply all of the oxygen, water, and power to operate Apollo 13 until shortly before the command module could enter the Earth's atmosphere. A similar abort procedure calling for the lunar module to help return a crew to Earth had been worked out early in the program in 1964 and was practiced in flight on the Apollo 9 mission. The Apollo 9 mission commander, Jim McDivitt, was at Mission Control and helped direct activation of the lifeboat procedures aboard Aquarius. The possibility of returning directly to Earth was quickly eliminated because the required 6,000 foot per second burn of the service propulsion engine could not be made without first separating from the lunar module. It was decided instead that the crew would move the entire spacecraft cluster back into a free return trajectory, fly around the backside of the moon, and return to Earth. At 61.5 hours after liftoff, the lunar module descent engine was fired to move Apollo 13 back into the free return trajectory. Many of the systems aboard the lunar module were then turned off to conserve electrical power and the water used to cool the electronic components. For the remainder of the mission until Earth entry, 2 of the astronauts normally worked and slept in the lunar module, while the other crew member remained in the darkened and cold command module. A 10-foot long hose taken from one of the lunar spacesuits was used to supply oxygen to the command module. As Apollo 13 flew around the backside of the moon, the spacecraft approached to within 156 miles of the surface. The astronauts, 2 of them on their first lunar mission, took time to photograph many of the surface features. Later, the decision was made not to drop the now useless 50,000-pound service module. Dropping it would have permitted a faster return to Earth. However, the guidance system aboard the spacecraft had not been programmed to fly through space without the service module attached. There was also some concern for the possible damage to the exposed heat shield if the service module had been jettisoned. As Apollo 13 emerged from behind the moon, preparations were made to burn the lunar module descent engine again to speed the return to Earth. A successful 4-minute burn reduced the travel time to Earth by 12 hours and changed the splashdown from an alternate area in the Indian Ocean back to the South Pacific. The spacecraft was then programmed into a slow rotating maneuver in order that the sun would uniformly heat the exterior surfaces. On the ground, fellow astronauts of the Apollo 13 crew and technicians at North American and Grumman worked many hours in simulators. They rehearsed every proposed maneuver and checked the use of consumables aboard Aquarius on a real-time basis. Mission Control also determined the best way to devise an air purifying system in the lunar module to keep carbon dioxide at a safe level. Lithium hydroxide canisters taken from the command module, rigged with plastic, cardboard, a sock, and held together by tape, helped keep the air clean in the lunar module. Several hours after the engine burn, the good word was passed up to Apollo 13. Consumables are doing better than expected. The margins are getting fatter. The crew would have sufficient oxygen and water to last through splashdown. However, life aboard the spacecraft was uncomfortable for the crew. Very damp and cold. Ken Mattingly, the original command module pilot, called the fourth member of the crew by Mission Control, had worked out mid-course maneuvers and re-entry procedures with other astronauts and technicians on the ground. He relayed the instructions to the crew members in Aquarius. A third burn of the lunar module engine on the 5th day of the mission was made to correct the flight path and raise the re-entry angle. Aquarius again performed admirably. A final correction on the last day of the mission assured landing on target in the Pacific Ocean. All the systems of the lunar module had been turned on prior to the final engine burn. 3 hours later, Swigert began to activate the systems of the command module and prepare for separation from the service module. 4½ hours before re-entry, the service module was separated.
Copy that.
Do you see it, Jack? Okay, I've got her right, Houston. And there's one whole side of that big missing. Right by the high gate antenna, the whole panel is blown out, almost from the base to the engine. Yeah, and Joe, looks like a lot of debris is just hanging out to the side near the S-band antenna.
The astronauts then returned to the command module, and the hatch connecting them with their lifeboat, the lunar module, was closed. Aquarius, a true spacecraft, was not designed to enter the Earth's atmosphere and had to be abandoned.
Farewell, Aquarius, and we thank you.
The command module entered the Earth's atmosphere at the predicted time and place. At 1 p.m. on April 17th, the parachutes of Apollo 13 were sighted above the Pacific water. Odyssey splashed down on schedule within 4 miles of the recovery ship. The USS Iwo Jima waited near the splashdown point. The crew, picked up by a recovery helicopter, were aboard the carrier within 45 minutes. Apollo 13 was home. The 6-day journey around the moon, the shortest Apollo lunar mission, was completed. An Apollo 13 review board was established by Dr. Thomas Paine, comprised of senior NASA officials and experts from other government agencies, industry, and the academic community. In conducting its intensive investigation, the board inspected the design and construction of the oxygen tank, reviewed all mission data and photographs, and interviewed the Apollo 13 crew. The board concluded that the probable cause of the incident was a short circuit in oxygen tank number 2, triggering combustion, which resulted in rupture of the tank. The flight of Apollo 13 was indeed a true odyssey, which Webster defines as an adventurous journey marked by changes of fortune. Although the mission did not accomplish its primary objective, many positive results were realized. In many ways, more has been learned for future space operations from this mission and the difficulties encountered than would have been learned from another flawless mission. International unity and concern were generated by the mission, with more than 13 nations offering assistance throughout the world. And present plans call for no major interruptions in the remaining flights of this nation's Apollo program.